Hey guys, welcome back. We are talking dynamics. We are officially into the fun part of the analysis. So this is impact, and this is energy loss example. What we've got is two blocks heading for collision. Block A is 5 kilograms. It's heading to the right. Let's call the right positive. It's heading to the right at 2 meters per second. Block B is going to the left at 1.5 meters per second. We are given that the coefficient of restitution is 0.8, and we're asked to find the velocities after impact and the energy loss during impact. So let's get started. From the last video, we know that we can use these equations to solve the system, and we have two unknowns, the VA prime, VB prime, so we're going to need both of them. And so let's see, MV, MA, VA prime plus MB, VB prime is equal to MA, VA plus MB, VB. So mass is 5, so 5 times V prime A plus 3 times V prime B is equal to 5 times 2 plus 3 times minus 1.5. That's going to give us that 5 times VA prime plus 3 VB prime. It's going to equal, what is it, 10 minus 4.5, so that's 5.5. Okay, and that's our first equation. Our second equation we get from the coefficient of restitution, and what is that? That is VA prime minus VB prime is equal to E times VB prime minus VA prime, or excuse me, not prime, VB minus VA. So let's see, let's solve this second one for VA, and then we'll substitute it in. So VA prime, I'm sorry, that's going to be equal to VB prime plus, let's see, that's 0.8 times VB is minus 1.5 minus 2. So that gives us VA prime equals VB prime. And that's going to be minus 2.8 meters per second. Okay. And so this is, we'll call this one 2. And we'll substitute number 2 into number 1. So we'll just replace VA with this. So what do we get? We get 5 times VB prime minus 2.8 plus 3 times VB prime equals 5.5. Okay, so 5 times VB prime minus 14 plus 3 times VB prime equals 15, equals 5.5. And if we collect like terms, then we add 14 to this side. That's going to be 19.5. This is 8 VB, so that means that VB prime is going to be equal to 19.5 divided by 8, which gives us V prime equals, what are we at here? It's going to be equal to 2.4, I get 375, so let's just go with, yeah, we'll just go with 4375 because we're going to be doing energy and pace to be precise there. And then we can substitute this 2.4375 into here, and that gives us VA prime. It's going to be equal to negative 0.3625. Both of these are meters per second. So that was straightforward. I still believe it's faster and easier to use matrices. I recommend them, but for a problem like this, you can substitute it pretty quickly. So let's look at the energy loss. Well, energy is kinetic plus potential. There's also heat and some other things, but in this context, we just look at potential and kinetic. There is no potential energy here, right? Because nothing is dependent on position. So we're really looking at the kinetic energy. Well, if we want the energy difference, then we calculate the kinetic energy before, the kinetic energy after, and then the difference is what's been gained or lost. So what we can say is we can say the change in energy is going to be equal to T minus T prime, right? So if T is the kinetic energy before impact and T prime is the kinetic energy after impact, then that should be the loss of energy. So let's calculate the kinetic energy before impact. So what is that? That is 1/2 mv squared. So 1/2 5 times v squared. So 2 squared plus 1/2 3 times 1.5 squared. And that gives us our initial kinetic energy. Let's see, 1/2 times 5 times 2 squared is 4 plus 1/2 times 3 times 1.5 squared. And that is 13.375. And what are the energy, or excuse me, what are the units of energy? Those are joules. Okay, so that's 1. So we want T prime, and same formula, 1/2 times 5 times, let's see, A is going to be minus 0.3625 squared plus 1/2 3 times 2.4375 squared. So T prime is going to equal 625 squared and this is 2.4375 squared, and this is 9.24 joules. Right, so dE is going to be equal to this minus this. Let's say minus this, and we get 4.134 joules. See if I got that right. See if it matches my notes. It does. Okay, so that is how we begin to calculate energy loss. This, by the way, the ability to go directly from impact to energy considerations is what makes this so much fun, and we will see that in not only this example, which I think is cool, but also in future examples and in our project. So thanks for watching, and I will see you in the next video.